Most people with diabetes wake up every morning thinking the damage was done the day before, the meal, the carbs, the one thing they feel they messed up. But what if the biggest influence on your morning blood sugar doesn't happen when you're eating, or exercising, or even awake? Here's the uncomfortable truth. Your blood sugar doesn't rest at night. While you're asleep, your liver is releasing glucose, your hormones are shifting, your nervous system is resetting, and your insulin sensitivity is being recalibrated for the next day. And the way you spend the final hours before bed quietly determines whether that process works with you or against you. Research in sleep and metabolic health now shows that disrupted sleep, irregular bedtimes, and poor nighttime routines are consistently linked to higher fasting glucose, worse insulin resistance, and rising A1C levels over time. Yet almost no one is taught how to use nighttime to their advantage. Doctors focus on food logs, medication timing, daytime activity. But the body does some of its most important blood sugar regulation while you're asleep. After reviewing sleep science, circadian biology, and diabetes research, what emerged wasn't a gimmick or a miracle. It was a pattern. Simple nighttime habits that quietly support glucose control while your body does what it was designed to do. These aren't shortcuts. They're not replacements for medical care. But they can make diabetes management feel less like a constant uphill fight. Today we're going to walk through 4 bedtime habits backed by current research. Habits discussed by clinicians who study sleep and metabolism and used by people who consistently see better morning numbers over time. By the end of this video, you'll understand how to turn nighttime from a blind spot into a powerful ally for blood sugar control. Let's begin. Habit 1. The strategic evening snack. Used intentionally, not automatically. For years, people have been told one simple rule: never eat before bed. And for many people, especially those without blood sugar issues, that advice works just fine. But diabetes changes the equation. Many people with diabetes experience a rise in blood sugar during the early morning hours, often called the dawn phenomenon. This happens because the body naturally increases glucose production overnight as part of its preparation for waking up. In people without diabetes, insulin responds appropriately and keeps glucose levels stable. In people with diabetes or insulin resistance, that response is often impaired, allowing glucose levels to climb unchecked. This is why some people wake up with higher blood sugar than they went to bed with, despite not eating anything overnight. Research suggests that, for certain individuals, a small low-carbohydrate, protein-focused snack in the evening may help stabilize this overnight pattern, not by feeding the body sugar, but by influencing hormonal signals that regulate liver glucose release. Protein digests slowly. It provides amino acids over several hours and can stimulate a modest insulin response. In some people, this appears to help reduce excessive glucose output from the liver during the night. But here's the key: this does not work for everyone. Studies comparing bedtime snacks consistently show that high-carbohydrate snacks worsen morning glucose. Protein-based or very low-carbohydrate snacks may be neutral or mildly beneficial for some individuals. Others do best with no snack at all. This is why personalization matters. If a bedtime snack is used, composition is critical. Slow-digesting proteins such as casein, found in cottage cheese or plain Greek yogurt, tend to cause fewer glucose fluctuations. Eggs are another low-carbohydrate option. Small portions of nuts may also work for some people due to their combination of protein and fat. Portion size is just as important as food choice. Large protein loads late at night are not helpful because excess protein can be converted into glucose through gluconeogenesis. This habit should never be automatic. It should be tested carefully by tracking morning fasting glucose and noticing patterns over several days. The goal is not eating at night. The goal is reducing unnecessary overnight glucose release. Habit 2. The evening walk. If there is one habit with the most consistent evidence behind it, this is it. After you eat dinner, glucose enters your bloodstream. If you remain sedentary for the rest of the evening, that glucose stays elevated longer, increasing stress on blood vessels, nerves, and metabolic systems. But muscle contraction changes everything. Even light movement activates glucose transporters in muscle cells that pull sugar out of the bloodstream without relying heavily on insulin. This is especially important for people with insulin resistance. Multiple studies published in diabetes and metabolic journals show that walking for as little as 10 to 20 minutes after a meal can significantly reduce post-meal glucose levels. This doesn't require speed, it doesn't require sweating, it doesn't require special equipment, it simply requires movement. Over time, when this becomes a consistent habit, the benefits compound. Regular post-dinner walking is associated with improved daily glucose patterns and modest but meaningful reductions in A1C. This habit also affects stress hormones. Cortisol, the body's primary stress hormone, signals the liver to release glucose. Evening walking has been shown to reduce cortisol levels, which can indirectly support better nighttime glucose control. There are mental benefits too. Many people notice that evening walking helps quiet racing thoughts, reduce anxiety, and create a psychological transition from the demands of the day into rest. This matters because mental stress directly affects blood sugar regulation. Sleep quality improves as well. Evening movement helps regulate circadian rhythm and build sleep pressure, making it easier to fall asleep and stay asleep. Better sleep then feeds back into better insulin sensitivity. The walk doesn't need to be long. 20 minutes is enough. Consistency matters far more than intensity. Habit 3. Reducing blue light exposure before bed. Light is one of the strongest signals to your internal clock. And modern lighting has changed that signal in ways the human body hasn't fully adapted to. Blue-enriched light emitted by phones, tablets, televisions, and LED screens tells the brain that it is daytime. When this signal occurs at night, it delays the body's natural transition into sleep. This matters because sleep is not just rest. Sleep is active metabolic regulation. Research shows that evening exposure to bright or blue-weighted light can impair insulin sensitivity and worsen glucose tolerance compared to dim or warm lighting conditions. One of the main mechanisms involves melatonin. Melatonin is often called the sleep hormone, but it also plays a role in metabolic signaling. Melatonin receptors exist in the pancreas, and normal nighttime melatonin patterns appear to support healthy insulin secretion and glucose regulation. When blue light suppresses melatonin night after night, sleep quality declines. Poor sleep is strongly associated with increased insulin resistance, higher fasting glucose, and difficulty controlling blood sugar over time. Sleep loss also disrupts appetite hormones, increasing hunger and cravings, particularly for carbohydrate-rich foods, the following day. This creates a feedback loop where poor sleep worsens glucose control and unstable glucose worsens sleep. This is why sleep researchers consistently recommend reducing screen exposure in the final 60 to 90 minutes before bed whenever possible. If screens must be used, lowering brightness, enabling warm light modes, or wearing blue light filtering glasses can reduce, but not eliminate, the impact. Replacing screens with lower stimulation activities makes a noticeable difference. Reading under warm lighting, gentle stretching, journaling, or quiet conversation helps signal the nervous system that it's time to slow down. Habit 4. Optimizing bedroom temperature. Sleep quality is closely tied to body temperature. To fall asleep and stay asleep, core body temperature naturally drops. Cooler sleeping environments support this process and are associated with improved sleep efficiency and deeper sleep stages. Deep sleep is when growth hormone is released, tissues are repaired, and metabolic regulation is reinforced. There is also evidence that mild cold exposure activates brown adipose tissue, a type of fat that uses glucose and fat to generate heat. Increased brown fat activity has been linked to improved insulin sensitivity in controlled research settings. This doesn't mean sleeping in extreme cold. It means avoiding overheating. Many sleep researchers suggest a bedroom temperature in the mid to upper 60s Fahrenheit as a general guideline, though comfort varies by individual. Sleeping in overly warm environments increases nighttime awakenings. Each awakening disrupts sleep cycles and can trigger stress hormones that interfere with glucose regulation. Better sleep from cooler environments has been associated with improved morning glucose readings in some individuals, though responses vary. Simple changes help. improving airflow, using breathable bedding, avoiding heavy blankets that trap heat, allowing the body's natural cooling process to occur. When you look at these habits together, something important emerges. None of them are extreme, none of them are complicated, and none of them work in isolation. Evening walking improves glucose handling. Reduced nighttime light supports circadian rhythm. Cooler sleep environments improve sleep depth. Optional individualized nutrition choices may stabilize overnight glucose. Together, they create conditions where the body can do what it's meant to do. One final factor amplifies all of them: consistency. Irregular sleep schedules, going to bed late one night, early the next, disrupt circadian rhythm and are consistently associated with worse insulin sensitivity and poorer glucose control. Going to bed and waking up at roughly the same time each day, including weekends, helps stabilize hormonal rhythms that regulate blood sugar. Tracking morning fasting glucose over time allows you to see how your body responds as these habits become routine. Better blood sugar control doesn't always come from doing more during the day. Sometimes it comes from giving your body the right conditions at night. Start with one habit, let it become automatic, then add the next. Over time, your mornings and your long-term numbers can begin to reflect that change.